Subscribe to our YouTube channel and press the bell icon to get the latest updates.
In the past few weeks, we've been seeing a fair amount of slightly confusing and conflicting information about the mechanism of transmission of the virus and the kind of precautions to adopt. There was a study recently that was sensationally misreported, but which basically found that if a COVID patient is in an unventilated room for long periods of time, even 6 feet of distancing from them wouldn't be enough to prevent transmission. The Indian government last month put out a statement saying that people should probably start masking indoors at home, which we all laughed at, but which is frankly a very alarming statement to make because it could indicate that secondary attack rate within households is very high. Then there are also people saying that we should stop disinfecting and stop washing hands. So what is actually happening? In this video, let's take a look at the science of how the virus actually spreads and what we know about transmission so far, so that we can understand and interpret all of these various studies and guidelines correctly and adopt the necessary precautions to be safe. I'm Sandhya Ramesh and this is Pure Science. Whenever we speak about the spread of the virus, one of the key terms we associate with transmission is aerosol spread. And this is, in very niche scientific circles, also a contentious term. The main debate is whether the primary mode of transmission is through droplets or aerosols or from surfaces. Let's look at surface transmission first. Surface or fomite transmission occurs when a viable virus or one that is able to infect is present on a surface and is touched, and the hand that touched it is then touched immediately to the face. Precautionary measures to prevent this are disinfecting surfaces and of course washing hands. Early in the pandemic, a number of studies claimed to reveal startling results for how long the SARS-CoV-2 virus survived on various surfaces. One early paper suggested that it could survive on metal and plastics for about 9 days based on existing lab studies of other coronaviruses like SARS and MERS. Another found out that the virus can survive on plastic surfaces for over 3 days, on cardboard for up to 8 hours, and so on. Such findings garnered quick attention, leading to persistent messaging around disinfection and sanitizing right from the early days of the COVID-19 pandemic. But our science was rapidly changing. There were some things where the changes were quickly adopted and in some places where they were not. Evidence started to show that fomite transmission wasn't really occurring all that much in real life, but the persistent messaging did not change, primarily also because it helps keep other diseases at bay. As the pandemic spread, aerosol experts started to sound the alarm on airborne transmission dynamics, requesting authorities to stress on the spread of the novel coronavirus through aerosols and not just droplets or contact with infected surfaces or persons. While the words airborne and aerosol are used interchangeably, they actually kind of mean different kinds of transmission, although slightly overlapping. Airborne transmission occurs when suspended particles of various sizes, including cuff droplets, are dispersed by air. Heavier droplets fall closer to the person who expels them, increasing risk of infection at close contact. When these droplets fall on surfaces, they become fomites. When they are airborne, the droplets are described as being airborne and the individual particles are also called aerosols. Humans produce respiratory droplets that range from about 0.1 micrometer to about 1000 micrometers in size. Larger droplets are thought to be anywhere between 5 and 1000 micrometers, while what we generally refer to as aerosols are less than 5 micrometers. The SARS-CoV-2 virus is approximately 0.1 micrometer in size. Aerosol transmission of a virus typically involves the virus either floating free in the air or latching onto other aerosols such as dust or pollutants, but mainly also phlegm and water, which can encase the virus particles before evaporating away and floating to large distances. Studies on fomite transmission have hardly yielded any real-world data. The only study or case we have had so far that indicates that the virus could have spread from contact with a surface was likely a transmission in China, where a live virus was found on the packaging of imported frozen seafood. 2 dock workers tested positive after handling the shipment, but it could not be confirmed that they contracted the virus because of contact with the packaging and not from an infected individual. So, the virus spreading from surfaces is hardly considered a major risk, and all forms of disinfection and sanitation and deep cleaning, all those expensive, comprehensive in-house cleaning for the virus, all of that is just a form of hygiene theater. None of that is going to help prevent transmission or kill the virus. The coronavirus spreads through both droplets and smaller aerosols, and this is well established. Other respiratory diseases like the common cold, measles, TB, and even chickenpox primarily spread through aerosols. Aerosols can be exhaled when simply breathing, when coughing, sneezing, and also when speaking and singing. Expulsive events like coughing and singing reportedly increase the distances they travel, as do louder voices. We have had many cases and case studies of aerosol spread. In May last year, the CDC meticulously reconstructed a super spreader event at a choir practice in Washington, where about 61 people had met for about 2.5 hours to sing and eat. The group included 1 symptomatic COVID patient, and within a week, 53 attendees had started to develop symptoms, 3 had to be hospitalized, and 2 had died. There have been other super spreader events and other clusters that have been linked to transmission indoors and in enclosed spaces like cruises, prisons, hospitals, all of which were attributed primarily to aerosol spread driven by air currents. One of the best known viral exposure event was described in a study by Chinese researchers last April that retraced multiple infections from one evening in an air-conditioned restaurant. A 5-member family, including an asymptomatic patient, ate there in January of last year. Within 2 weeks, 9 others who had dined at the restaurant on the same day fell sick. 4 were relatives of the index patient, but 5 others had caught the virus when seated on 2 different tables, along with others who did not get infected. The study researchers noted that the infected individuals had been seated in the path of the airflow from the air conditioning unit near the infected index patient. They concluded that virus transmission in this outbreak cannot be explained by droplet transmission alone. And of course, if these aerosols move around in the wind, they will also not move around and accumulate too much when there is no air circulation. So this risks build up inside unventilated spaces. There have been studies, such as one a few months ago on ferrets that were separated by levels but connected by a PVC pipe with 90-degree turns. This experiment showed that aerosols linger in the air and transmitted over distances greater than 1 meter. Many studies have shown that aerosols spread in very different ways than we normally think in poorly ventilated spaces, especially because they're so small with such a small mass. In conditions like low humidity, they can stay adrift for long periods of time due to upward air currents and forces that we don't normally tend to think about. Within the scientific community, there is a bit of contention, and we can also often see this debate spill over outside, and that is whether the primary mode of spread of this virus is through droplets at near range or aerosols that are capable of floating to far distances. One of the biggest challenges of obtaining data for aerosol transmission is that our technology is not yet where we need it. Capturing viable virus from the air is difficult, as the process of sampling itself could leave the virus unviable or effectively dead. But despite that, there is evidence of aerosol transmission, and it is not really that intuitively difficult to understand how this occurs. The easiest way to understand how to distance and protect oneself when surrounded by people is to assume that every single person around us is smoking a cigarette. So how do we move around so that we completely avoid all cigarette smoke? So we know that if we're in an unventilated space, we'll come in contact with the smoke. If we're too close to a person, we can smell the smoke. Even if a place is ventilated and we're further away from a person, but there's wind current will be in the path of the smoke. So that's a preliminary easy test to understand aerosol transmission. One of the easiest ways to make indoor settings safer from aerosol transmission is opening windows and encouraging cross ventilation. Air filters and air purifiers are also an advantage indoors. If ventilation is not adequate, even if we're physically distanced and we're double masking or wearing an N95, we could still be at risk. So at the end of the day, irrespective of whether the primary mode of transmission is droplets or aerosols, the basic precautionary measures work for all of us for the most part to keep numbers under control. First is, of course, physical distancing. The farther we are, the better. The next is masking, and at this point, double masking is highly recommended for everyone wearing the more protective mask on the inside or wearing an N95. And ventilation is always key. Lastly, experts do urge that we continue washing our hands anyway, because it is likely that it does contribute to breaking the chain of transmission, and it definitely does help keeping other diseases away, which is crucial when health systems are so overwhelmed.